So this is October, November 2023, paper 23. Question number one says the elements phosphorus, sulfur, and chlorine in period three. Okay. Of the periodic table. Table 1.1 shows some properties of the elements phosphorus to chlorine, the first ionization energy of phosphorus, the first ionization energy of sulfur is not shown. Okay. Number of electrons in 3p subshell. Number of electrons in 3p subshell. So we have to first draw electronic configuration, right? Phosphorus is 15, okay? So 1s2, then 2s2, then 2p6, then 3s2, and then 3p. This is 3p, 6, 10 plus 2, 12, and then this is 3p3. This is what? This is 3p3, okay? So how many number of electrons in 3p subshell? I would write 3. I would write 3. And how many electrons in sulfur? Sulfur would be, sulfur is 16. It's 3p4. 4 electrons in the 3p, in the 3p. Okay. And then, uh, and then you will see that in chlorine, chlorine is 17. So it would be 3p5. So I would say 5. Okay. I would say 3p5. It's very simple. It's very easy. And then the total number of unpaired electron. If you can see the total number of, if you can see the total number of unpaired electron, okay, total number of unpaired electron. So I would say that it has total 3p3. It's 3p3. So if you can see 3p3, so that is just like that, 1 and 2. 1, then 2, then 3. It's 3p3, like 3 unpaired electrons in it. Okay. And sulfur is 3p4. It would be 3p4. So how many unpaired electrons? 2. And 3p5. 3p5 means that it has only one unpaired electron. Okay. Construct an equation to represent the first ionization energy of phosphorus. Of course, you know that ionization is the loss of electron, and after the loss of electron, it would be having a positive charge. So I would be writing phosphorus gas would be losing one electron, would be forming P positive in the form of gas, would be forming P positive in the form of gas. Okay. And then the three possible values for the first ionization energy of sulfur are given. Click circle the correct value. Explain your choice by comparing your chosen value to those of phosphorus and chlorine. So I would say that um, they have given you the value and they are asking the three possible values for the first ionization energy of sulfur are given. So circle the correct value. So if you remember when we were discussing ionization energy, so I told you that there is some exceptional cases between the ionization energy of phosphorus and sulfur, okay? Because as you go across the period, across the period ionization energy decreases, but there is some exceptional cases like we have magnesium and aluminum, beryllium and boron, nitrogen and oxygen, phosphorus and sulfur. So the ionization energy of sulfur would be lower than the phosphorus. It should be higher, but it is lower. So you know what I would be doing? So the ionization energy of sulfur would be lower. So if the ionization energy of phosphorus is 1060, so that would be 1000. That would be 1000. Okay. Because these values are greater than the 1060 and 1320. That's not possible because we know that theoretically the ionization energy of sulfur is lower. So what I would be writing, they are saying, explain your choice. Explain your choice. So, like I would say that sulfur has nuclear attraction, lower nuclear attraction to the outer electron, okay, then phosphorus, then phosphorus, okay, and And I would say that I would say that um, it is of 4 marks. Okay, it is of 4 marks. Uh, and then lower nuclear charge. Sulfur has lower nuclear charge. Okay, lower nuclear charge than chlorine. Okay, and if you can see the electronic configuration of sulfur is 3p4. It's 3p4. 3p4 means that it would be just like that. Okay, so sulfur has two electrons in sulfur has two electrons in 3p orbital, 3p orbital, which results spin pair repulsion. Spin pair repulsion. And due to this, we can remove electron easily from the outer electron of sulfur, from the outer shell of sulfur. Simple. Okay. Uh, then see this one, part B. Phosphide, sulfide, and chloride have the same number of electrons. Give the full electronic configuration of phosphide, P3 minus. Already phosphorus has 15 electrons. When it would be gaining 3 more electrons, it would be 18 in total. That would be 1s2, then 2s2, then 2p6, then 3s2, then 3p6, that is 18. State the trend in ionic radius shown by phosphide, sulfide, and chloride. Explain your answer. So I would say that ionic radius, it's going to decrease across the period. Why is going to decrease? Because the nuclear attraction is going to increase, is going to decrease, is going to nuclear attraction is going to decrease, right? So, like if the like ionic radius ionic radius is inversely proportional to the nuclear attraction, okay. If the nuclear attraction is higher, so the ionic radius would be smaller. If the nuclear attraction is lower, so the ionic radius would be higher. This is of 2 marks. I would say that ionic radius decreases, from phosphorus to chlorine, okay, due to, as as shielding remains same, as shielding remains same and nuclear attraction increases. Nuclear attraction increases, and also nuclear charge increases. Like I'm going to draw phosphorus and chlorine or sulfur. You can see that 2 electrons, and then we have 8 electrons, and then we have And then we have phosphorus is 15. Okay, phosphorus is 15, but it has three more electrons. It would be 18. So how many protons are there in the nucleus? 15 protons. Same structure would be for the sulfur. Okay, same structure, but it would be having how many protons? 16 protons. How many protons? 16 protons. That's what I'm saying. Shielding remains same. You know why shielding remains same? Because the total shell remains same. And of course, the proton number increases. So when the proton number increases and also when the shielding remains same, so to cancel the same effect, I'm going to remove inner shells because I know the shielding is same. Inner, like the repulsion between inner electrons are same. So I'm going to cancel this. I'm going to remove so that I can study the force of attraction between the nucleus and the outer electron. So the nuclear attraction for sulfur is higher because sulfur has more protons. So due to the greater nuclear attraction, the electron would be coming towards the nucleus, which results in lowering the ionic radius. So that's why I have written that the nuclear attraction increases. Due to the increase in nuclear attraction and also the nuclear charge increases, so overall I can say that ionic radius is going to decrease. Okay. A student does three tests on separate samples of sodium chloride. First of all, he added addition of few drops of bromine aqueous. Since you know that bromine is less reactive than chlorine, as you go down the group, I'm talking about halogens, as you go down the group, the reactivity of halogen decreases. Okay, so bromine is less reactive. So there would be no reaction. There would be no reaction. Okay, no visible, no visible, no visible reaction. No visible reaction. And then they are saying concentrated addition of a few drops of concentrated sulfuric acid in sodium chloride, like they're doing like that. Concentrated sulfuric acid, um, again, I would say that it's a simple NaSO4 and HCl. So there is no change in color. There is no change in color. All are colorless. All are colorless. So no visible reaction, no visible observation, nothing, nothing. So solutions are colorless. So I would not see anything. Then addition of few drops of dilute silver nitrate. Of course, we have sodium chloride, so silver nitrate would be reacting with chloride. It would be forming silver chloride. So I would see the white precipitate. I would see the white precipitate. Simple, okay? Then POCl3 shows similar chemical properties to PCl5. POCl3 has a melting point of 1 degree Celsius and a boiling point of 106 degrees Celsius. POCl3 reacts vigorously with water, forming misty fumes and an acidic solution. Explain how the information in D suggests the structure and bonding of POCl3 is simple covalent. Remember, covalent compounds are going to have lower boiling and melting point, okay? And ionic compounds are having high melting and boiling point. You know this. It's a simple concept, okay? So so they have given us 106 boiling point, okay? And melting point is 1 degree Celsius. Of course, they are lower. Of course, they are lower. Why they are lower? Due to weaker intermolecular forces. Okay, due to weaker intermolecular forces. And they are saying POCl3 reacts vigorously with water, forming misty fumes and an acidic solution. Suggests the structure and bonding of POCl3 is simple covalent. So this is of 2 marks. First of all, I would be writing that POCl3 is a simple covalent as it has relatively low boiling point and melting point due to weaker IMF. Due to weaker IMF. Due to
weaker IMF. Okay. And they were saying in the reaction that they were saying in the reaction how the explain how the information in D suggests the structure and bonding of POCl3 in simple covalent, so relatively low melting in boiling point, and also I can say that they would be having a weaker intermolecular force. Okay. And they are doing basically this reaction when they are going to add POCl3 reacts vigorously with water, forming misty fumes and an acidic solution. Okay. So basically this is hydrolysis. Basically this is hydrolysis. Covalent compound does hydrolysis. Ionic compound does not. This is the concept. Remember, as reaction and and vigorous reaction with water says this is hydrolysis. Construct an equation for the reaction of POCl3 with water. So when POCl3 is going to react with water, it would be forming H3PO4. It would be forming H3PO4 along with HCl. Then you have to balance this equation. So I would be writing 3 hydrogens and 3 2s are 6, because total 6 hydrogens we have in the product side. That's the balanced chemical equation. Okay. Then dot and cross diagram. How many electrons are there in the outer shell of phosphorus? Phosphorus is in group 5. So it has 5 electrons. Okay. And chlorine has 7 outer electrons. And oxygen has 6 outer electrons. Hmm. Okay. So how many electrons are needed oxygen to complete their outer shell? 2 electrons, of course. Okay. Oxygen needs more 2 electrons to complete its outer shell. Okay. And each chlorine is going to have one more electron to complete its outer shell. Okay. So what I would be writing over there, so you can see this, that we have first of all oxygen. Okay. We have oxygen, and then we have, you can say, chlorine. Then we have chlorine, and how many electrons phosphorus has? So you can say 5. So 1, then 2, then 3, then 4, then 5. So this is chlorine, chlorine, and chlorine. So each and every element is having a full electronic configuration. Full electronic configuration. Okay. Okay. Then POCl3 forms when PCl3 reacts with O2. Table 1.3 gives some relevant data. Define enthalpy change of formation, that is delta HF. So it's enthalpy change when one mole of a compound is formed from its constituent elements in their standard states. Calculate the bond energy of P double bond O in POCl3 using the data in table 1.3. So PCl3. So PCl3. They're asking the bond energy. They're asking the bond energy. So how I would be doing this question? They have given you oxygen value, that is 496, of course, and they have given you the overall. Uh, okay. Yeah, enthalpy change of formation of PCl3 they have given to you. Enthalpy change of formation of POCl3 they have given to you, that is minus 592. That is the overall value. That is the overall value. So the delta H is equal to reactant minus sorry, product minus reactant, because this is delta H. Product minus reactant. Product product minus reactant. Okay. So no, they're asking about the bond energy. So I have to apply the formula reactant minus product, okay? Because they're discussing about the bond energy. So the delta H is given to you, that is minus 592, okay? As you can see, minus 592. According to the equation, we have 2 POCl3. So I would be multiplying this by 2. And reactant is PCl3, that is minus 289 multiplied by 2, since the coefficient is 2. And then we have O2. O2 is 496. I would be writing 496 positive. And then minus product, minus product, minus product. So we have POCl3. We have, and PCl3 is given to you. PCl3 is given to you, that is like 289 that I have put over there. Okay. Now what I have to do in POCl3, you would see that this is phosphorus and oxygen, and this is going to have this one. This is going to have this one. Okay. This is going to have this one. So how many 2POCl3 we have? 2POCl3. So I would be writing 2x. X is this one. We have to find out PO. We have to find out PO. It's very simple. Okay. And this is of like 2 marks. So what's the answer? What's the answer? Yes. Yeah, what's the answer? Yeah. The answer should be positive 551. Are you getting this? Are you getting this answer? Yes or no?
Yeah.
Okay. And then they are saying state the variation in solubilities of group 2 hydroxide. I told you solubility of group 2 hydroxide increases down the group. What is observed in reaction 1? What is observed in reaction 1? You can see it is barium. You can see it's barium oxide. You can see it's barium oxide. So barium oxide is solid. Barium oxide is solid at room temperature. So when it would be reacting with water, okay, when it would be reacting with water, so it would be forming barium hydroxide. It would be forming barium hydroxide, and you can write down that you can write down like the solid disappear. You can write down that like the solid disappear. Okay, the solid disappear. So solid disappears, and this is white solid. Okay, it's not transition metal. Suggest a reactant for reaction 2. Suggest a reactant for reaction 2. When I am going to get barium carbonate from barium hydroxide, so what should be the reactant? Like to that reactant, I can react barium hydroxide and I can get barium carbonate. Of course, that would be carbon dioxide. That would be carbon dioxide. Identify a when barium hydroxide is reacting with the ethanoic acid. Of course, this is an acid and this is a base. It would be forming salt. So it would be forming Chiku. This would be Chiku. And since the valency of barium is 2, this is in group 2, it would be forming this. And barium hydroxide is made by the reaction of barium with water. Write an equation for this reaction. So when barium is going to react with water, since barium is more reactive, as we go down the group, the reactivity of metal increases. It would be forming salt and hydrogen gas. To balance this equation, I would be writing this. Okay. Or yeah, the equation is balanced. And then the mineral peritocalcite contains both barium carbonate and calcium carbonate. Both compounds decompose on heating. State which compound decomposes first when peritocalcite is heated. Explain your answer. State which compound decomposes first. I told you regarding the thermal stability of carbonate. It increases down the group. It increases down the group. It increases down the group. Okay. So calcium, like barium carbonate, is more thermally stable. So of course, who will decompose first? Who will decompose first? Of course, calcium carbonate. As thermal stability of carbonate increases down the group. Okay. Can you tell me the next one? The formula of Berry to calcite is this one. Construct an equation for the complete thermal decomposition. When you are going to heat this one, so it would be giving you, of course, barium oxide, and it would be giving you calcium oxide, and it would be giving you carbon dioxide. So these are the decomposition products. So they would be forming metal oxide. Whatever the metal you have, they would be forming metal oxide. Okay. And then barium hydroxide is used to hydrolyze organic compounds. Draw the structures of the organic products of the process. Organic product 1, barium hydroxide, then HNO3. Organic product 1 and organic product 2. Okay. So so they are saying this is your ester. This is your ester. Okay, this is your ester. So when you would be hydrolyzing this ester in the presence of in the presence of acid, that is nitric acid, or in the presence of base, that is your like barium hydroxide. Okay, so what would be the product? So what would be the product? So I can say that that would be like it's gonna be, you can see this. Okay, would be breaking down. The first one would be this, and the second one would be the this one. Simple. Because this is nitrile cyanide, it would hydrolyze. It would hydrolyze. It would be giving you, it would be giving you carboxylic acid. Hydrolysis of nitrile is going to give you carboxylic acid. Okay. Chaji. Potassium chlorate is widely used as an oxidizing agent and to make O2. Define oxidizing agent. So oxidizing agent is the one which oxidizes other and reduces itself. Substance which oxidize other, substance which oxidizes other and reduces itself. Substance which oxidizes other and reduces itself. Okay. KClO3 decomposes when heated. MnO2 catalyzes the exothermic decomposition reaction. Complete and label the diagram in figure 3.1 to show the effect of MnO2 on the decomposition of KClO3. So they are going to ask to draw the graph. So this is the reactant and this is the product. Complete and label the diagram to show the effect of MnO2. Like MnO2 is using as a catalyst, of course. Okay, MnO2 is used as a catalyst. So it would be forming this product, okay, and then it would be forming this product. So this one is with catalyst because the activation energy is lower, and this one is without catalyst. This one is without catalyst because the activation energy is higher. Okay. Explain why this reaction is described as a I told you what is disproportionation reaction. Same species is oxidized and reduced. है ना? I told you disproportionation reaction is the one in which the same species is oxidized and reduced. So I can say that in this reaction, chlorine is +5 and this is +3. Yep, and this is -1. So chlorine is both oxidized and reduced. Molten KClO3 reacts with glucose. Show your working, give your answer to three significant figures. So I would be applying the formula, that is PV is equal to nRT. PV is equal to nRT. They are asking to calculate the volume. I would be calculating the volume in this way. Okay. So I don't know the moles. I don't know the moles. So what I would be doing for moles, I think so. They have mentioned the moles. Hmm? So use this ideal gas equation to calculate the volume in meter cube of 1 mole of gas. 1 times 8.314 times temperature is 630 Kelvin divided by the pressure. The pressure is 1 exponent 5 Pascal. 1 exponent 5 Pascal. Okay. So can you tell me an answer? Can you tell me an answer? Yes, what's the answer? Yes, what's the answer?
So the answer is 0.0524.
0.0524. This is the volume in meter cube. This is the volume in meter cube. Then they are saying 5 grams of glucose reacts completely with molten KClO3. Use your answer to D part 1 to calculate the total volume of gas released at 630 Kelvin at 1 exponent 5 Pascal in this reaction. If you are unable to know, no, we have calculated. So 5 grams of glucose. Use your answer to calculate total volume of gas released. So how I would be doing this question? Okay, so uh, they are saying they are saying use your answer to D part 1. In D part 1 I got 0.0524. That was the volume of 1 mole of gas. That's the reaction. That's the reaction. 1 mole of gas. Like they are asked, like we have calculated volume of 1 mole of gas. You know gas is this? Gas is carbon dioxide. Okay, they have given us the mass of this glucose which is going to react completely with this molten KClO3. So what I would be doing, because I have to calculate the total volume of gas released, so that would be, and also this is also the gas water molecule. So how many molecules, total moles we have? 12 moles of gas released. 12 moles of gas released. What is the mole ratio? 1 is to 12. 1 is to 12. C6H12O6 into the total gas, that is 1 is to 12. 1 is to 12. Okay. So so I have this one that is 5. I need to calculate the moles first. 5 over the molecular mass of glucose, that is 180. So can you tell me the number of moles of glucose? Yes, moles of glucose. 5 upon 180.
0.028.
0.028. Would be x. This would be x. So you have to just cross multiply this and you would be getting your answer. You would be getting your answer. That's it. Okay. Mhm. But what's the answer? What's the answer?
0.33.
X is equal to 0.33. So if I was getting the volume of for 1 mole of gas, and if I have this much moles, so what would be the volume? I'm going to multiply this by 0.0524. So the answer is, what?
0.017.
Yeah, this is in meter cube. Okay, 0.0175. Then the structure of glucose is this: primary, secondary, number of groups. So primary, this one is primary. Okay, we have only one primary. Secondary, 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 secondary. So we have four secondary, and tertiary is 0. There is no tertiary. Separate samples of aqueous glucose are tested with the reagents shown in table 3.2. Complete the table 3.2. Write no reaction if applicable. Acidified KMnO4 and then warm. Acidified KMnO4. So when you would be adding an oxidizing agent, that is KMnO4 in glucose, so it can oxidize this glucose. It can oxidize this glucose, into what? Into carbon dioxide and water. So the KMnO4 would be changing its color from purple to colorless. Purple to purple to colorless. Failing solution. Failing solution can only react with aldehyde, right? It can only react with aldehyde. Okay. So what I would be looking at, if it would be reacting with an aldehyde, so what would be the color of Fehling solution? Is there any aldehyde? Is there any aldehyde in this structure? Yeah, is there is aldehyde. So what would be the observation? Red PPT. Red, I would see the red PPT. Alkaline aqueous iodine. For the alkaline aqueous iodine, we must have this group. There is no any this there is no such group. There is no such group in this. Okay. And also, if we have this one, so it would be giving us positive test. So I would write there is no reaction. I would write there is no reaction. Define structural isomers. So I would say that molecule with the same molecular formula but different structural formula. Give the systematic name of D. Give the systematic name of D. D is this 1, 2, 3, 4. So we have 3 at like 3 methyl. Methyl is present at the third position. 3 methyl. But 1 ene. Double bond is present at the first carbon. Explain why C and D do not show geometrical isomer. I told you that there should not be the same group attached with the double bond carbon. Okay. So the reason is this is of only 1 mark. Okay. I would say that carbon carbon double bond has the same groups attached. Draw the structure of a molecule that is a positional isomer of C and D. I can change only the position of the double bond. Okay. Is a positional isomer of C and D. So I would be writing the 4 carbon atoms just like that. I can only change the position of the double bond. So I would be doing just like that. Simple. Give the structural formula for the compound form D when D reacts with H2 in the presence of platinum. When we are going to react it with a platinum catalyst, basically we are going to do hydrogenation. Hydrogenation means what? Addition of hydrogen. What would be the product? Alkene would be converting into alkane. Okay. So they are saying give the structural formula. So it would be CH3, then CH, then CH3, then CH2, then CH3. Okay. Okay. So CH3, I'm copying this. This is your answer. C can form an addition polymer. Draw the structure of one repeat unit of this addition polymer. We have to eliminate the double bond. We have to eliminate the double bond. They are asking about C. So what I would be doing, this carbon is going to have 2 CH3s and this carbon is going to have 1 CH3 and 1 hydrogen. These are the like the continuous structure because this is the polymer. Okay. So that's the answer. The mass spectrum of C shows a molecular ion peak at mass to charge ratio 70. This peak has a relative intensity of 48.7. The relative intensity of the M plus 1 peak is 2.7. Show that this information is consistent with the molecular formula of C. I got I got molecular formula of C that was 1234 1234, that is C4H8. C is going to have C is C4H8, like means that, am I right? No. Five carbon. One, two, three, four. Yeah, five carbon atoms. Okay. It's C5. It's not C4. It's C5 and H10. So H10. So means that when I would be calculating the number of carbon atoms, so I should get 5. I should get 5. Okay. So that would be n equals to 100 over 1.1. That's the formula. Multiplied by m plus 1 peak divided by m plus peak. So 100 over 1.1 multiplied by m plus 1 peak is 2.7 divided by the m plus peak, that is 48.7. So of course I would be getting 5. Simple. Around I would be getting 5. C and D both react with HBr. Complete C reacts with HBr to form E. Complete the diagram in figure 4.2 to show the mechanism for this reaction. Draw the structure of the organic intermediate. Include charges, dipoles, lone pairs of electrons, and curly arrows as appropriate. So, it's going to have partial positive, partial negative. This double bond is going to attack on this. This is going to be removed. And of course, I would be writing this one. Okay. Like hydrogen, and this is going to be positive. Then Br minus would be attacking on this just like that, and it will be forming this. It's very simple. D reacts with HBr to produce F, a chiral bromoalkane. Draw the structure of F. Draw the structure of F. D for doctor. D reacts with D. This is the structure for D. This is the structure for D. First carbon atom has a double covalent bond. So they are saying it would be reacting with HBr. So this is just like that. I think so, yeah. So it would be forming, you know what? This is going to be H, this is going to be Br. This is the structure. I'm not supposed to draw H because this is the display structural, like skeletal formula. We are not supposed to show carbon and hydrogen there. Why the reaction of HBr with C and D produces different major products? Because in C we have this is the one I'm talking about, this tertiary carbocation. This is secondary. This is secondary carbocation. Tertiary is more stable than secondary. Okay, tertiary is more stable than secondary, right? So, why the reaction of HBr with C and D produces different major product. So C has tertiary carbocation and D is carbocation. Okay, so means that D is going to have a secondary carbocation, or I can say the primary carbocation. Okay, like D has two carbocations, tertiary and then secondary. Like C has tertiary carbocation and secondary carbocation, just like that.
Sir, in tertiary carbocation, you have like three branches coming out, right? And in secondary, you
Yeah,
have like only two, right?
yeah, exactly. Yeah, exactly.
Okay.
And D has secondary and primary carbocation. And primary carbocation. So C. C is more stable as it has tertiary carbocation, or I'm supposed to write C has tertiary carbocation, okay, as more stable due to more alkyl groups attached. More alkyl groups attached, okay, as alkyl groups have positive inductive effect. Okay, that's simple. That's simple. And okay. This is D, and then this is. They are talking about the. Okay, this is going to be end. Nice. C to E HBr and E to J. E to J. E to J. Of course, this is Br, and it would be having H. So the possibility is that C can be used to form H. One possible synthesis of H is shown. Different portions of C are used in reactions. Some of the products are then combined to produce H. Does not show any of the inorganic product of the reaction. Okay. Then J plus G is going to give you this product. And G. So J is going to give you aster, aster. And okay. So aster means that aster can be produced by the reaction of alcohol and carboxylic acid. By the reaction of alcohol and carboxylic acid. So I think so it should react with NaOH. I think it should react with NaOH, and it can give you the same answer but with OH. Bromine, it would be replaced by NaOH. Okay. Okay. And then C gives G plus this. C gives this plus G plus this one. So C is double bonded. C is double bonded. So, we have to oxidize this double bond like hot KMnO4. It's going to give you ketone. It's going to give you ketone and then carboxylic acid. Of course, it would be acidified. Acidified KMnO4. Hot. J plus G gives H. J plus G gives H. Of course, this is going to be formed like esterification. So concentrated H2SO4, concentrated H2SO4, okay, which is used as a catalyst. It's very simple. This is related to the synthesis. So before going to do this question, your organic chemistry should be very good. Your organic chemistry should be very good. Like I'm talking about the reagents and conditions. Okay.